I am Florian Lehmann and I will present our paper, Typing Behavior is About More Than Speed. User Strategies for Choosing Word Suggestions Despite Slower Typing Rates. I worked on this project together with my colleagues Itto Kornecki, Daniel Buschek and Anna Maria Feit. This screenshot shows a typical keyboard view on iOS. In the top half, you can see a web application where people had to transcribe English sentences, and in the bottom half is a typical mobile keyboard with a bar displaying suggestions. With our work, we focused on analyzing the typing behavior of mobile keyboards and looked into their suggestion usage. Our main findings and contributions were the following. We found that people who type slower use suggestions more often, and by doing so, they are even more slowed down. We identified 8 strategies users employ when they use suggestions. And based on our findings, we built a selection model that involves such strategies and demonstrate how it could be combined with an existing keyboard algorithm. But what do we already know about suggestion usage? We know that cognitive cost may outweigh performance, as related work has shown. Also, word suggestion users were slower typists. However, it is a popular feature. Suggestions reduce the typing effort and can improve the typing experience. Because of that, the goal of this work is to better understand the way in which people make use of word suggestions when they type on their own smartphones. For our work, we relied on data from Palin and colleagues. In their work, people had to transcribe up to 15 sentences in English. They collected interaction data from almost 40,000 volunteers. We took their data, applied some filtering, and arrived at interactions from about 15,000 volunteers. We computed 4 different speeds for our analysis. First, the natural speed. This might be comparable to measuring motor performance. We excluded the use of word suggestions and only involved lowercase letters that are preceded by lowercase letters. And we only involved common words that were shorter than 5 characters. The letter-only speed is similar to the natural speed, but involves also longer words. This speed includes cognitive processes, considering suggestions and reviewing words from that suggestion list. Then, the letter and selection speed. Here we involve also the selection of these suggestions. And finally, the overall speed, which involves all keystrokes and is equivalent to speed measures like characters per second. In the first part of our work, we looked into the suggestion usage and typing performance. For that, we separated the users into non-suggestion users and suggestion users based on how often they made use of the feature. We first looked into the natural typing speed. Here you can see distributions for both groups, and you can see that suggestion users type slower. After that, we looked into the effect of manual typed words per selected suggestion on typing speed. Here we found the more words are typed without suggestions, so the faster the overall speed is. And here you can see a comparison of speeds between the groups. All comparisons show a lower typing speed for suggestion users. In particular, the letter and selection speed shows the biggest difference here. We could say suggestion users are even more slowed down by selecting suggestions. In the second part of our work, we wanted to understand the strategies for selecting word suggestions. And we chose a semi-qualitative approach for doing so. First, we manually inspected the dataset and used our domain knowledge to build first hypotheses about strategy use, and then we implemented rule-based classifiers. We iterated these steps to narrow down a list of strategies. We finally arrived at 8 strategies, where completion and correction were the most used strategies. We found that for both strategies, suggestions were used for rather long words, and suggestions for both strategies were used for rather uncommon words. So the probability is higher to use suggestions for words that are rather infrequently used in English. Looking at the speed before selecting a suggestion, we found differences too. Users type slower before using the suggestion for completing a word compared to correcting a word. But how could we use these findings in a practical application? We built a selection model that computes a probability based on a set of features that represents the current input of the user, the characteristics of a suggested word, for example, the length, and the strategy that would be invoked by selecting the word from the suggestion list. The probability of the selection model would then be combined with the probability of the already existing keyboard model. And now I want to show you an example to demonstrate how we could combine our selection model with an already existing keyboard algorithm. In this example, the user would like to type "I love musicals." Let's suppose the user typed already "I love M." In the first step, the user would type an U, which results in "I love mu." In the second step, the keyboard algorithm would compute probabilities for each of the suggestions. My would have a rather high probability with 0.5, followed by music and musicals. In step 3, we would infer the strategy. My would be a correction, music a completion, musicals a completion too. In step 4, our selection model would then compute probabilities. Now, musicals would have the highest probability here with 0.2, because it's a rather long and infrequent word. In step 5, we would then combine probabilities of the keyboard algorithm and our selection model. In step 6, we could then use these probabilities to re-rank these suggestions. Here we could present the top 2 suggestions in descending order, which would be musicals and music. In step 7, we would have to repeat the steps 2 to 7 every time a user inserts a new character. Again, the main findings and contributions of our work were the following. Slower typists use suggestions more often but are slowed down by doing so. We identified 8 user strategies people employ for using suggestions. And we created a selection model and demonstrate how we could use our findings practically. We discussed in our paper that slow typists use suggestions more often. We mainly see 2 reasons for that. On the one hand, the cognitive costs. People have to switch their gaze between the keyboard, the suggestion list, and the written text. As well, they have to think about when to integrate these suggestions into their own text. On the other hand, there might be motivations that go beyond speed, such as the strategies we have identified. And finally, we argue that future intelligent text entry methods should be designed for more than performance. For instance, user intent or user agency.